Good morning everyone. Today I am here to discuss the concept of combustion, and what you need to know about it. We'll be exploring the requirements for combustion, the ignition temperature, and the role of air in the burning process. So let's begin. Combustible substances are materials that can burn in air and generate heat and light. These include wood, coal, charcoal, kerosene, petrol, diesel, liquefied petroleum gas, LPG, and compressed natural gas, CNG. When these combustible substances are burned under optimal conditions, they serve as a source of energy, providing light and heat. To ensure safe and efficient use of combustible substances, it is vital to comprehend the fundamentals of combustion. Combustion is a chemical process involving heat that is produced when a combustible substance interacts with oxygen. Known as fuels, combustible substances burn when heated to a certain temperature, referred to as the ignition temperature. As a result of combustion, a flame or a glow may be produced. To understand and control combustion and its risks, it is essential to be aware of these conditions. For the fourth slide, we can observe the need for air to make a combustible material available for burning. In the experiment described, we can see that air is necessary for burning to occur. When the chimney is open and resting on wooden blocks, the flame burns freely. When the wooden blocks are removed, the flame stops burning. And when a glass plate is placed over the chimney, the flame does not burn at all. This experiment shows that air is necessary for the burning of a combustible material. A substance's ignition temperature is the lowest temperature at which it will ignite and burn. Varying materials have different ignition temperatures, for instance kerosene and wood. Some materials have very low ignition temperatures, and can be ignited by simply exposing them to a flame. These are known as combustible substances, like gasoline, ethanol, LPG, and CNG. As such, these materials must be used with extreme caution, and ample attention should be dedicated to safety procedures. For combustion to occur, the three essential conditions must be met. Fuel. Air to supply oxygen and heat to raise the temperature beyond the ignition temperature. If any of these conditions are lacking or insufficient, combustion will not happen. Knowing and controlling these conditions safely is essential for successful combustion. Fire safety is an essential element in any setting. In order to effectively manage a fire, it is essential to first understand what is needed to ignite a fire. The three main conditions necessary for fire to occur are fuel, oxygen, and heat at an ignition temperature. To contain a fire, one or multiple of the conditions must be eliminated. The most efficient way of doing this is via a fire extinguisher. Fire extinguishers are useful in cutting off the oxygen supply or decreasing the temperature of the fuel, or both. Firefighters are also trained to efficiently use fire extinguishers and other fire safety equipment to protect lives and properties. Fire is a hazardous risk that needs to be managed cautiously. There are numerous ways to control fire, each with its own benefits and downsides. Water is the most usual fire extinguisher and can be used to put out fires caused by materials such as wood and paper. Nonetheless, water should not be employed for electrical equipment, or for fires ignited by oil or petrol, since they will float on the water and still keep burning. Carbon dioxide is the optimal fire extinguisher for these varieties of fires. Carbon dioxide is heavier than air, thus it covers the fire and breaks off the supply of oxygen, putting the fire out. It is held under intense pressure as a liquid in cylinders, and chemicals such as sodium or potassium bicarbonate can be employed to generate carbon dioxide at the fire. Fire management is critical for safety, and recognizing the multiple methods available can help to protect possessions and individuals from the effects of fire. Combustion is the process of burning which requires oxygen, heat, and a fuel source. Rapid combustion occurs when a fuel source, such as LPG, is exposed to an external source of heat. Spontaneous combustion takes place when a fuel source, such as phosphorus, burns without an outside heat source, usually at room temperature. Explosion combustion is observed when a fuel source, such as a firework, is exposed to heat or pressure, and it burns suddenly, producing heat, light, and sound. The types of combustion that exist range from the common and familiar to the more advanced and explosive. These include spontaneous combustion, where substances can suddenly catch fire without any external ignition source, fireworks, that are combinations of combustible material formulated to burn in certain colors and patterns, and rapid combustion, which is the process of burning with a high rate of speed, even when the ignition temperature has been reached. We also have spontaneous combustion, which is the sudden and spontaneous ignition of combustible material, as well as explosions, which involve the sudden combustion of inflammable materials with an intense release of energy. Finally, we have gas 460, which is a flammable gas used in internal combustion engines. When combustible substances burn, they may or may not produce a flame depending on the material and its characteristics. Examples of materials that will produce a flame when burned include kerosene and wax. On the other hand, materials such as coal and charcoal will not produce a flame. Each combustible material will produce energy through combustion, but the process can vary and lead to different results. The accompanying pictures illustrate different types of flames and their corresponding characteristics. Composed of multiple layers of heat byproducts, the candle flame has a distinct purpose in each. The outer zone is blue-colored, due to the presence of oxygen, and is the least hot. The middle zone is yellow and is moderately hot, where partial combustion of the wax vapors occur. The inner zone is black and is the hottest, with complete combustion happening. This area is further divided into two subzones: the luminous zone, and the non-luminous zone. The non-luminous zone is the hottest and is where the chemical reactions happen that keep the flame alight. The structure of a candle flame is composed of three main zones. The outer zone, situated on the outside of the flame, is where complete combustion of the fuel takes place, giving off a blue and hot flame, which is the non-luminous part. The middle zone is where partial combustion occurs, resulting in a yellow and moderately hot flame, which is the luminous part of the flame. The inner zone is where unburnt vapors of the fuel reside, the flame being black and being the least hot part. Premise of combustion can be improved by understanding different types of fuels that can be used in the process. These fuels can be divided in three categories: solid, liquid, and gaseous. Solid fuels consist of wood, coal, and charcoal. Liquid fuels like kerosene, petrol, and diesel. And lastly, gaseous fuels such as CNG, LPG, biogas, and hydrogen. Each fuel has its own properties and applications, and by recognizing these characteristics, combustion and safety protocols can be improved. Considering all of the qualities that are important for a good fuel, it is important to take into account availability, cost-effectiveness, storage and transportability, rate of burn, heat output, and lack of residual substances or pollution. All of these characteristics should be considered before selecting the best fuel for a particular job. The calorific value of a fuel is the measure of how much energy can be generated from burning a unit of that fuel, expressed in kilojoules per kilogram. Counting cake has a calorific value of between 6,000 and 8,000. Wood has a calorific value of between 17,000 and 22,000. Coal can range from 25,000 to 33,000. Petrol and kerosene have a calorific value of 45,000. Diesel has a calorific value of 45,000. Methane, CNG and LPG have a calorific value of 50,000. Biogas has a range of 35,000 to 40,000. And hydrogen has a calorific value of an impressive 150000. Hydrogen has the highest calorific value among all fuels. Burning of fuels has a damaging effect on the environment. The byproducts of burning can be toxic or cause health problems such as respiratory issues or even death in some cases. Carbon dioxide, released from burning of coal and petroleum, is the main cause of global warming, leading to a melting of polar ice, an increase in sea levels, and flooding of coastal areas. Furthermore, oxides of sulfur and nitrogen released from burning dissolve in rainwater and form acid rain, damaging crops, soil and buildings. It is our responsibility to ensure that we burn resources safely and responsibly to protect our environment.